Alright, so I just saw somebody trying to do this. Whoops. This. So 0 to an imaginary power. 0 to the I. What does that give you? And the way he goes about it, which seems reasonable at first, is he does this. He's like, well, x is the same as e to the ln of x, right? So that all is the same as this. And then that will be the same as e to the I times ln of x. So if we just plug in 0, we're going to get something nice, right? Well, and we can carry this further, right? So this is cos ln of x plus I sine ln of x. Right, like that. And then the problem that you get is when you put 0 in here, what power do you raise e to give you 0? That's the question. That's what this is. That's why ln of x is undefined. Right? But does that matter? Does this equation actually is this even valid in this situation? That's my question. Right? So if we look at how exponentiation works, what it is it's really you take 1 whenever you're doing any exponent, you start with 1, your multiplicative identity, your dimensionless multiplicative identity 1. And you multiply it by the base exponent number of times. Okay? Now, all that's happening here, the only difference between this being a 1 and an I is that it is a different dimension. But 0 simultaneously exists in all possible dimensions. So this isn't really a problem. 0 is everywhere all at once. It's the same thing. So if you're multiplying it by, if you're taking it to the first power in one dimension, it shouldn't behave differently than if you take it to the first power in a different dimension, in a perpendicular dimension. Right? So if 0 to the first, well here, I'll first outline this, right? So like 2 to the third, let's put another space in there. 2 to the third is 1 times 2 3 times, right? So we get times 2 once, times 2 twice, times 2 3 times. Computationally, that yields 8. 2 to the 0 gives you 1. And then we don't do anything with the base. So it doesn't matter what the base is, right? We can actually just replace this with a variable like x. And you can see here the base is fucking irrelevant. Right, so one of the things that he said here in the video was that 0 to the 0 is undefined. And you shouldn't be confusing this with the limit from the right-hand side of 0 to the 0, which is 1. And no, he's wrong. 0 to the 0 is computationally 1 if you understand how exponents work. Because the base does not come into play. It does not matter what your base is. Anything to the 0 power is 1 if you understand how exponents work. Conventional mathematics does not. So that's where you end up with all this fucking confusion. But it is definitely necessarily 1. And you can see that when we do this. You can see that 1 is pervasive everywhere, right? Because here, well, let's do this like the negative 3, right? So if we're doing a negative exponent, a positive exponent is multiplication. A negative exponent, the negative means the opposite of. So the opposite of multiplication is division, right? So you're going to take your 1 that you always start with, and you're going to divide. And then you're going to divide. And then you're going to divide, because our exponent, the numerical component of that is 3. So we do it 3 times. And then computationally, that is 1/8. And conventionally, you won't write in the 1 when you do this unless it is to the 0 power or it's a negative exponent. If it's a positive exponent, we tend not to write in the 1, and that is where the cultural confusion about what the fuck is happening here comes from. We'll say that 2 to the third is 2 times itself 3 times. That is the standard English phrase for this. 2 to the third is 2 times itself 3 times. But if you pay attention to that, 2 times itself 3 times is 2 times 2 times 2 times 2. 3 multiplications, that is 2 to the 4th. So we're saying it wrong, and we're thinking about it wrong. You start with 1, and you multiply that. 1 times base exponent times. Thus, 2 to the third equals 1 times 2 times 2 times 2. Yeah, so up here, the 1/8 and the 8 is if I was using 2. Okay, so from here, what the fuck is happening with zeros? Well, 0 to the first power is just going to be 1 times 0. That's 0. Okay. 0 to the negative first power is going to be 1 divided by 0. Conventionally, this is undefined. And the reason why is totally, it makes sense. It's totally reasonable. Actually, my reason for having Desmos up is, oh well. Okay, so yes, this is conventionally undefined because it's not math. There's nothing here that's accessible to conventional number theory. But logically, think about it. -1 is the same really as 1, it's just in the opposite direction. Right? We're doing the opposite thing. But we can change our reference frame so that negative is positive very, very easily. So why now suddenly what was negative now is positive? No, it would work and it would just be 0. And this is a possible solution anyway. So we might as well just go with this for right now. You know, it's a tentative equals. Maybe it's not a whole equals. Because we're not 100% confident in this. But for practical purposes, it's 0. Now, 0 to the I is basically the same sort of thing. We can just change the dimension that we're considering to be I, the imaginary dimension, and we're changing which dimension we're considering to be the real dimension, which is something you can totally fucking do. It's totally random. And now, it should just be the same as 0 to the first. Except now we're operating in the imaginary direction, so that's still 0. So the fact that Euler's formula does not work here isn't actually a problem, because the way in which it's undefined doesn't actually tell us that we can't know this. Okay, yeah, I am going to actually show it here, right? So the problem is, look at this. When we have 0, when x is 0, what is the natural logarithm of that? Is it negative infinity? No, actually. It actually isn't. Because if we were taking the limit of it, we would get negative infinity. Right, so the limit as x approaches 0 from the right of ln of x equals negative infinity, right? So what this is doing, this is actually saying that the natural logarithm of L of 0 equals negative infinity. But recall, L of 0 is not the same as 0, right? So this is not true. This is important. This is important. This is an important fine detail, because what it means is this doesn't tell us jack shit other than this doesn't work here. That's all we know. All we know is that this equation doesn't tell us the answer to this. That's it. But logically, it should be 0. Because as long as you're raising to anything other than the 0 power, some multiplication involving 0 is going to come into play. It could be an inverse multiplication, which is division, or it could be a direct multiplication. In either case, you very plausibly get 0 anyway. And if we just rotate our reference frame around, you can guarantee that you'll get 0. Nothing else could ever be guaranteed. So, this tells us something deeper about the foundations of mathematics. And it's based in just understanding how exponents work. So I call bullshit on him saying that this is undefined. It's 0. And I don't care what the limits look like. It's 0. Feel free to disagree. Because there is definitely, I am definitely diverging from conventional mathematics here. So, you are 100% warranted to disagree. Feel free.